Hi everybody, welcome to another video in Business Calculus, section 11.3, L'Hopital rule. This should be with the hat, L'Hopital rule, like that. Right, before we go to L'Hopital rule, let's review the infinite limits and the limit and infinity. So, let's first look at the limit of this function. So when x go to 3, the superscript minus meaning from the left hand side, and so if we put 3 in here, 3 minus 3 is 0. So bottom line is we have 2 over 3 minus 3 cubed, and that is 2. 0 cube is 0, right? Now we just need to determine it go to 0. So this is not equal to 0 at the point. It is approaching to 0 from the bottom. So we need to know if it is approaching from the positive side or negative side. So this is easy, and we use calculator for that. So let's say we have a number from 3, from the left side of 3, meaning that we have 2.99999, very small, close to 3. We do that down to x, and then we get x minus 3 cube. So we have a negative number, a very small number, but it's negative. So if we have a finite, have a number, and when we divide by the number, it gets smaller and smaller and close to 0. Let's say we start with 2, for example, and we divide by 1, that's 2. Now we divide by a smaller number. Sorry, forget the decimal. A smaller number we divide is by the bigger number we get. But this time we have a negative, so this will be negative infinity. Right, next. Again, if we put 3 to it, it will be 0. Let's just make it clear. If we go from the left side, it will be negative. Right, now if we go from the right side of 3, so 3 point, so that is the right side of 3. Let's do that. And we have x minus 3 cube, and that's going to be positive and positive. So that gives us positive infinity. Well, from the left side is negative infinity, from the right side is positive infinity, so the limit does not exist. Next, I'll find the limit for x equal to 2. So when we're trying to find the limit, the first thing we do is just put in the number. And then we have square root of 0 divided by 6, which is 0 divided by 6. 0 divided by anything other than 0 is 0. So that is a defined number. So we just make it equal to. So right. So 0 divided by anything is 0. 0 divided by 0 is indefinite, indeterminate form. Let's just write out what we have at this point, right? So a summary of what we have earlier. 0 divided by something that is not 0, just like what we have here is 0. So that's the first one. Right. If we have something other than 0, which is what we have here, divided by 0, that in general is undefined, or we can say it could be plus or minus infinity. So that's what we have in this scenario, or could be undefined. But then again, negative or positive infinity are not a real number, so we could say them that they are undefined. And then 0 over 0 is indeterminate. Right. So that's what we have previous in the first chapter in this class. Right now, let's look at infinity as well. So infinity divided by something that is not infinity, which is finite. Because when we mean infinity, we could be plus or minus, and that of course still plus or minus infinity. Now if we have a finite number divided by plus or minus infinity, a finite amount divided by bigger and bigger number, the bigger number we divide by, the smaller the quotient we get. Essentially it goes to 0. And then infinity over infinity is indeterminate. Right, so that's what we have earlier. Now let's look at the limit of exponential function and logarithmic function. I'll just look at the basic of the natural log and natural exponential function. So exponential function e to the x looks like this. So what we focus on is what happened at the limits. So we say I'm just going to say e to the infinity is going to be infinity. That's the wrong way to write, but we should write as x goes to infinity, e to the x is equal to infinity. Right. So when x goes to infinity, e to the infinity is infinity. Now when x goes to negative infinity, we just say limit of e to the x as x goes to negative infinity is equal to 0. Right, so that's what we have. Focus on an exponential function. And the logarithmic function is the inverse of exponential function. So it goes like this. Natural log of x. And we have limit at x goes to infinity of ln of x. We go to infinity. So ln of infinity is infinity. Now, notice that ln of x only defined for x being positive. So that the graph only on the right side of the y-axis. So we say at x go to 0 from the right hand side of ln of x, that equal to negative infinity. Right? So exponential function when x go to infinity, it is equal to infinity, and go to negative infinity, that is 0. Or we can write like this: e to infinity is infinity, and e to negative infinity is equal to 0. And then ln we can write the same way. Ln of something that goes to infinity is equal to infinity. Ln of something that goes to 0 from the right hand side is equal to negative infinity. Right. So keep that in mind so we can go to the next section, next part of the section. Right, L'Hopital rule. By the way, if we cannot write the hat like we said earlier, it's I think it's Italian or French, but if we cannot type the hat, we can just write the S like that. Right, first review indeterminate form. So we have two indeterminate form here. This is where the top goes to 0, the bottom go to 0 when x go to the limit. So this we will have what we call the 0 over 0 indeterminate. And we could also have infinity over infinity. It could be positive, could be negative, but in general we just write like that. So that is also indeterminate. So what is said in the L'Hopital rule, by the way, these two rules are the same. This different indeterminate form. So L'Hopital rule in general is saying that if the limit in the indeterminate form, either that or that, either 0 over 0 or infinity over infinity, then we can take derivative of the top and derivative of the bottom. Note that this is not a quotient rule. Quotient rule is u prime v minus uv prime over v squared. We don't have that. We just have derivative of the top over derivative of the bottom. It says that the limit of the ratio of the function is equal to the limit of the ratio of the derivative, only if they are in indeterminate form. If they are not in indeterminate form, we cannot use the L'Hopital rule. So that's rule number 1, only for indeterminate forms. Second, it is not a quotient rule. We take derivative of the top divided by derivative of the bottom. And then the last part is just the fine print saying that it works for one-sided limit as well. It also works when x goes to infinity as well. So it could go to any number from the left side, from the right side, or that number could be infinity as well. As long as they are in indeterminate forms, we can use the L'Hopital rule. Right, then let's look at the first example. Right here we have this. Of course, the first rule of find limit is put in the numbers. See what happens if I put in 2 square minus 4 over 2 square minus 3 times 2 plus 2. Alright, the top we have 4 minus 4 0. The bottom 4 plus 2 minus 6 is 0. So that a check. So this is in indeterminate form. So that means we can use the L'Hopital rule. Of course, back in the very few section, if the both of them equal to 0, that means they share the common factor, and then we factor and then simplify them. We're not doing that here. What we do is we take derivative of the top over derivative of the bottom. For the first step, I'm going to just write out the top. I'll take derivative of that, and then the bottom. Because when we used to it, we can just skip this step. I'll take derivative of bottom. Right. Derivative of x squared minus 4 is 2x. Derivative of x squared minus 2x plus 2 is 2x minus 3. Alright. Now put in the numbers. See what happened. You put 2 in for x. The top is 4. The bottom is 4 minus 3 is 1. So this is equal to 4. And that is well defined number. So we'll make the limit equal to that. So simple enough. The L'Hopital rule allows us to find the limit without have to factor. So that's a nice way to do it. The first rule of limit is always put in numbers. See what happens. Right. Now put 1 in for x, e to the first minus e over 1 minus 1. Right. e to the first power is e minus e is 0, 1 minus 1 is 0, so that is indeterminate form. So if it is in indeterminate form, we can use L'Hopital rule. So derivative of the top, derivative of e to the x is e to the x. Derivative of e, that constant is 0. So on the top, that's what we have. Derivative of x is 1, derivative of 1 is 0. So that's just that. So we just have limit of e to the x, and then put 1 in for x. That's just e, and we make the limit equal to that. So very simple. If it is indeterminate form, then use the L'Hopital rule. Take the derivative of the top, derivative of the bottom, and find the new limit. Right, next we have this one. Limit as x go to 0 of ln of 1 plus x squared divided by x to the 4th. Right, first I put in 0 for x, 0 for x. So I have ln of 1 over 0, 1. I need to go back to the previous, the first page of this note. We have the exponential function and logarithmic function. There are two important things here. What we see is this special point e to 0 power is equal to 1. So anything raised to 0 power is 1. And as for the log of any base of 1 is equal to 0. Right, so we need to know that special point along with what happened at the limits, what happened at infinity. Sorry. Right, so ln of 1 is equal to 0. Of course, if you don't know that, ln of 1. Right. So once again, this is indeterminate form. Got to check. So we use L'Hopital rule. Right, derivative at the bottom is easy, 4x cubed. Now on the top, we have ln of something. Derivative of ln of something is 1 over that, parentheses, and then derivative of the parentheses. So let's simplify this a little bit. 4x cubed. Right, we have 1 over 1 plus x squared. 1 plus x squared, derivative of 1 is 0, derivative of x squared is 2x. So put 2x on the top. And then 1 plus x squared. And then 4x cubed. Right. We can write 4x cubed over 1. That's still the same thing. So we're going to flip it, meaning multiply reciprocal. Yeah, x squared plus 1 or 1 plus x squared, same thing. And then 1 over 4x cubed. Yeah, multiply reciprocal, so we flip. And then multiply straight across. We have 2x on the top. And then at the bottom, 4x cubed times that. Oh, run out of space here, but 4x to the 5th plus 4x cubed. Alright. Now we put in 0 in again. We have 0 over 0 again. Right, because there's x. So we take derivative one more time. So it says that sometimes we have to use the Hospital rule one more time. And then, so that is in indeterminate form. If we use the Hospital rule one more time, give us 2 on the top, and at the bottom we have 20x to the 4th plus 12x squared. And then we put 0 in, we have 2 over 0. Well, that is undefined. And by the way, because that is to an even power, both of them are positive. So we have like that, which is infinity. Right? Because for something like that, we can let's look at the graph and see what happened. Have a fraction of ln of x squared plus 1. Of course, over x to the 4th. Yeah, you see, when x goes to 0 from the left side and the right side, it is infinity. Right? So that's what we have. I'm sorry, I should write the answer in here as well. So keep using the Hospital rule. We have limit x go to 0 over 2 20x to the 4th plus 12x squared. That 2 over 0, but it's positive because both of them to an even power cannot be negative, so that equal to infinity. Right, this one, first thing, of course, we're going to put 1 in for x. So ln of 1 over 1. ln of 1 is 0. 0 divided by 1 is 0. So this one is not in determinate form. It is just a well-defined number, 0. So if it is a defined number, we just make it equal to. Right, so do not use the Hospital rule if it is not in determinate form. In this case, just 0 divided by 1, which is 0. So obviously that. Right, so don't use the Hospital rule if it is not in determinate form. If we substitute in a number that equal to a nice, by nice I mean a defined number, not infinity or something undefined. If it's the case, just make them equal to. Right. Next we have this. Now we're going to put 0 in for x. Notice we do not make it equal to because we don't know what it is. It could be undefined, it could be indeterminate, it could be something. So we're not writing equal. We write equal if it ends up being a defined number. Right, so 0, e to 0 power is 1. 1 minus 1. So we have 0 over 0, which is indeterminate. So if it is indeterminate, we can use the Hospital rule. Derivative of x squared is 2x. Derivative of e to the x is e to the x. Derivative of x is 1. Right, that's good. We have a new limit. Let's put in 0, see what happens. That gives us 0 on the top. At the bottom, e to 0 power is 1. Once again, we have 0 over 0, which is indeterminate. So that means we can use the Hospital rule again. So derivative of 2x is 2. Derivative of e to the x is still e to the x. Derivative of 1, that constant. Derivative of constant is 0. So derivative of the top is 2. Derivative of the bottom, e to the x. Now we put in the number again. E to 0 power is 1, and this time it is 2, a defined number. So we make it equal to it. Right, so that's all we have. So this is the first indeterminate form of 0 over 0. Next we will have the indeterminate form of the form infinity over infinity. Right, let's look at the first example. By the way, we did something like this earlier, and we said as x goes to infinity, only the highest power matters. So we simplify this equal to 2 over 3. That's it. And by the way, that's the way we should do it. But in this case, let's put in infinity. But as I mentioned before, when something like this, only the one with the highest power matters. So even though you said, okay, 2 to infinity is infinity, minus 5 times infinity is negative infinity, right? So look like here we have the 2 times infinity square is infinity, and 5 minus infinity is minus infinity. In fact, infinity minus infinity is a form of indeterminate as well. But it's not going to be, in this case, it's not in that, because we did mention that way back in the first few sections, when we have a polynomial like this, as x goes to infinity, only the highest term matters. So it doesn't matter the rest. So we have this and that, which is infinity over infinity. So indeterminate form. Infinity over infinity. So we'll use the Hospital rule. Derivative of 2x is 4x. 2x squared is 4x. Derivative of 5x is 5. The bottom derivative of 2x squared is 6x. Right. Same thing, put in infinity. So we have infinity over infinity. And also indeterminate form. So we can use the Hospital rule. Derivative of the top for x minus 5, derivative of that is 4. Derivative of 6x is 6. 4 over 6 is 2/3. This is just 2/3. There's no x to substitute in, so that's 2/3. By the way, on the first few sections, we said as x goes to infinity, only the highest power matters, and so only those 2 terms matter. And all we do after that, cancel the x squared and the x squared. We have 2 over 3, which is exactly what we have. So actually that's the way we should do. As x goes to infinity, the highest power term matters, and we'll just do that and simplify the problem. Right. Now, limit of x squared over e to the x as x go to infinity. First thing, of course, put in a limit, see what happens. Infinity square over e to infinity. Infinity square is still infinity, and e to infinity. We have that on the first page of this section. For e to the x, it go to infinity as x go to infinity. So we have infinity over infinity indeterminate. So that means we use the L'Hopital rule. Derivative of x squared is 2x. Derivative at the bottom, e to the x. Derivative of e to the x is e to the x. Right, put in a number again. So we have 2 times infinity is infinity. E to the infinity is still infinity. So that once again is indeterminate. And that means L'Hopital rule again. Derivative of 2x is 2. Derivative of e to the x is still e to the x. As you see, for e to the x, we take in derivative, it still give us e to the x. Now we have e to infinity. That 2 over infinity. A finite divided by infinity, that is 0. So this limit equal to 0. Right. Next, we have that. Right. So, of course, if we put in negative infinity, we have negative infinity square times e to the negative infinity. By the way, that is infinity and that is infinity. So this is not indeterminate form, and we just have infinity. That's not one way to do that. Another way is just rewrite this as we have x squared still on top, e to negative x. If we move to the bottom, that becomes e to the x. Then put in the numbers, see what happens. Negative infinity square, e to negative infinity. E to negative infinity is going to be 0. So have infinity on the top, 0 at the bottom. Well, this is not indeterminate form. We have a very big number divided by a very small. So that's going to be infinity, of course. So we're not using the L'Hopital rule here because they are not indeterminate form. So we have a very big number divided by smaller and smaller number. Eventually that infinity. Or we already have that. Next we have this. First, put it in infinity, see what happens. So that is infinity over infinity. And that is indeterminate. One of the indeterminate form. So that means we use the L'Hopital rule. Take derivative of ln of x is 1 over x. Derivative of 2x cubed is 6x squared. And we can write that over 1. so we can multiply reciprocal. Notice the difference in the equal sign. If it is the L'Hopital rule, I will write the L'Hopital rule on the top. So that means we take the derivative of the top and the bottom. This one, we just rewrite the complicated fraction by multiply the reciprocal. Right? So that's just a normal equal to, not the L'Hopital rule. 1 over 6x cubed. Now put in infinity, see what happens. So give us infinity cube is still infinity times 6 infinity. So finite divided by infinity, that would be 0. Yeah, kind of like that. A finite number divided by infinity is going to be 0. Right. So the most important in the L'Hopital rule is when we put in the numbers. First, see what happened. Only use the L'Hopital rule for indeterminate forms. And because by now we know that is not the quotient rule. We just take the derivative of the top, derivative of the bottom. And sometimes we have to do the L'Hopital rule more than one time, like this. And with that, we finish section 11.3. Thank you for watching, and see you in another video in business calculus.